Bismillahirrahmanirrahim. So first thing first, let's connect the USB cable to the flight controller. Alright, and connect the other end of USB to your computer. And remember that you should download the latest version of ground control station software of OpenPilot CC3D, otherwise there will be a mismatch. So I have downloaded the OpenPilot CC3D on my computer. Alright, what I'm going to do is I think the best thing is that I also record my screen. Okay, so let me turn on the screen recorder. Where are you? So I can actually put very clear picture of what's happening inside the computer. Okay, I'm gonna use the Camtasia Studio to record the full screen. Okay, now we are here in the OpenPilot ground control station software. What we are going to do first is check that your USB copter control is connected and the data is already showing you that the data is transferring to your flight controller and from your flight controller. Click on the vehicle setup wizard, okay, and remember, please do not install the propellers. That is why I went ahead and offered people the self-tightening propellers, so they are very easy to mount and very easy to remove. Okay, no more tightening and stuff like that. So remove all your propellers. Okay, click next. Click on erase all settings. Check erase all settings because you want to erase everything from this board, and click on upgrade. Don't touch your quadcopter. This will upgrade the firmware to your flight controller. Make sure you're connected to internet at this time because it might download the firmware from internet. Alright, firmware uploaded, booting and erasing the board. Okay, so it has been erased and board is updated. Click next. Click next. Choose PWM or PPM or S-Bus according to your setup. I'm using PWM. One cable for each channel. Click next. Multi-rotor. Select multi-rotor. Click next. Select from this list Quadcopter X. So you can see motor 1, motor 2, motor 3, motor 4, and we have done in the previous step all the motors and ESCs connected according to this diagram. Okay, according to this diagram we have connected all this stuff to the flight controller, all the ESCs to the flight controller, and we have also made sure motors are spinning according to this diagram, and we have installed the propeller adapters clockwise and counterclockwise accordingly, so when motors spin your propeller will tighten rather than flying away. Click next. Choose rapid ESCs. Click next, and now it's time for you to calculate the and now on this stage we will be calibrating the sensors. So click calculate, make sure quadcopter is perfectly leveled and don't touch it. Don't move anything. Let the sensors sit stationary and calculate everything. When it says done, click next. Now is the most critical step, that is you're going to calibrate all your ESCs at once. So make sure there are no propellers installed. Click I have removed all propellers. Check the vehicle is not powered by external power source but USB. Check I confirm and read and understood above instructions clearly. If something goes wrong, I am responsible. Anyway, so now you are going to click on start. So your flight controller is giving full throttle to ESCs. Connect the battery. You will hear two beeps. Click stop. One long beep. all your ESCs have been throttle calibrated. Disconnect the battery. Okay, and go next. Now, of course, connect the battery again, because now you're going to program the other aspects. That means you're going to make sure motor neutral level is found. Click next, and now you're on motor 1. Click start and move the slider until the motor starts moving. I think this is 1096. I will stop. Next, start for motor 2. See where the motor idles. 1096. Good. Next, motor 3, start. And okay, 1096, the motor is perfectly idling. Next, start. 1096, motor is perfectly idling. And stop. Sometimes maybe you have to drag the slider a little bit left and right to see where actually motor will idle. But for me, because I have done this setup before, I know most of the motors with the Hobbywing X rotor will actually idle perfectly at 1096. But again, check your own values. Let each motor idle on its own. Next, on the next window, select current tuning. Okay, and go for next. Click save. Your controller is rebooting. Good. Now next step is transmitter setup wizard. Okay, so now you know we have programmed our Futaba radio. Make sure these mixings are off, because we have created the mix using channel because we are creating the mixes using switch G and switch D. We will turn off all the mixings. We will turn on our radio transmitter and start the transmitter setup wizard. Select always disarmed. Of course it will be. Go next. Choose acro mode, normal transmitter. Go next. Mode 2. Well, I'm using mode 2. If you're using mode 1, that throttle at the right, choose accordingly. I'm using mode 2, throttle on the left. Click next. Now move the sticks according to the sticks shown on the screen. Follow them. And this one is for switch. Other 3 channels I'm not going to use, so I'm going to skip, skip, skip. Now center all the sticks, click next, and move all the sticks to their full extent. Okay? Because this is your sticks calibration to find out where is the endpoints or where they have the maximum points. Click next, and now here on this screen you can reverse if anything is not working right. So check. My throttle is working right. My rudder is working right. My ailerons are working right. My elevators are working right. If anything need to be reversed, you have been given throttle, roll, pitch, yaw. You can always reverse them at this screen. If nothing to be reversed, click next, and for the last time, check all your channels are working in right direction. Click next, and from this drop-down menu, choose how you want armed, how you want the motors to be armed. So I will choose yaw right and click save. Now check, if I move, if I do yaw right, my GCS should tell me motors are armed.
Armed.
Okay, she says armed and disarmed. Alright, so our CC3D programming is done perfectly using the wizard. That was piece of cake. Now comes the tweaking, the PID settings. So I have some very trusted, tested PID settings that I'm going to show you and put them right here. But before that, go to the flight mode switch settings. Okay, and here you, because we have set the 3-position switch on the radio to use flight modes. So on the stabilized one, I will choose attitude mode. That's where I will be using my tilting and benefit from the tilting. My stabilized 2, I will move it to ratitude. For roll, ratitude for pitch, and rate for the yaw. Thrust manual. What is ratitude? Ratitude means your quadcopter flight Ratitude means the flight controller will fly the quadcopter in attitude mode, but when you move the sticks to their maximum, quadcopter will flip in that direction. So if you want to roll, so when you're flying, it's flying like in attitude mode, okay, when you're moving the sticks, and when you move the sticks to the max, quadcopter will flip in that direction. So you can do normally very slow rolls and flips, you can do in ratitude mode. The third mode, I don't want to set on rate, I want to set it on acro plus. And yaw is rate. So roll and pitch is acro plus on the third one. Now, once again, this is your switch C. First is stabilize mode. No matter how much you move the sticks to the extent, your quadcopter will not flip and always will be in a stabilized mode. Second, in the middle on the switch, it is ratitude mode. It will fly in attitude or stabilized mode, but when I move the sticks to the extent, quadcopter will flip, making rolls or loops in that direction. And when I put the switch C completely down, I am in acro plus mode. That means everything is completely manual, okay? So that means quadcopter will behave in completely crazy, insane way depending on the PIDs that you have set. So this is done. We have set just now 3 flight modes successfully. We will click on save. And now we will go to the stabilization. Uncheck the basic configuration. Go to advanced. Okay, now this is where you will put in the values that I will provide on the next screen. So pause it and note it down, or just email me and I will send you the picture or upload it to my website so you can download. I will upload the screenshot of this after setting the values, so you can download this screenshot and you can put in exactly the same values in your PID settings. So here are my CC3D settings. This picture I can send for you easily. And now what I'm going to do is I'm going to add the same values to my CC3D here. So going ahead to CC3D, advanced configuration, attitude mode response degrees 75, and yaw is 180. Rate mode response is going to be a bit crazy, so 400, 400, 300. 400, 400, 300. The next is max rate limit, that is 360, 360, 300. So 360 on roll, 360 on pitch, and 300 on yaw. Well, you can increase on yaw as well if you want your yaw to be crazy, so I'll make it 350 here. Okay. Next, we are going to use rate or inner loop, rate stabilization and inner loop, that is 200, that is 0.2, that is 0.00225, 0.00265, 0.00600. So 225, 265, 600. Change it 225. Well, I'll just 220. 265, so 260 and 600. Alright, the next one is I. So just now we have set the P, now we are going to set the I, which is 0.00400, 0.00550, 0.00520. So 400, 550, 520. I'm gonna put it to 400, 550 and 520. Next we have D values, derivative, that is, you know, the last 2 digits are 40, 45 and 20. So 40, 45 and 20. Now comes the attitude stabilization, that is outer loop. For that you want to go on less values. So instead of 1.822 I will go 1.6 or 1.7, 1.8, and yaw is 1.8. We will leave them to 0. Now for the enable TPS, thrust PID scaling, check enable TPS, okay, and select from this drop down menu manual control throttle. And the affect, and the affected values should be PID values. This means according to higher throttle, your flight controller will adjust the PIDs itself, so you will not have that dreaded oscillation. Axis that will be affected will be roll and pitch. Okay, I will uncheck enable pyro compensation. I will uncheck this one and nothing else to be done. This is done. Don't click on setting banks 2, don't click on setting banks 3. Just use one bank and click on save. I will click many times to make sure it saves always. Why we use only one bank? Because when we go to stabilize mode, flight mode switch settings, you can see in stabilize 1, stabilize 2, stabilize 3, we have bank 1, bank 1, bank 1. If you want different settings in different flight modes, you can always go to stabilization and set different values in different banks. So you have 3 different banks, and in the input web menu here, you can flight mode switch settings. You can use stabilize mode 2, bank 2, stabilize mode 3, bank 3. So that depends on you. For me, bank 1, I set everything and I use same bank 1 settings for all flight modes, and it works simply perfect and keeps the things very, very simple. Hit save once again, click on disconnect, disconnect power, turn off the radio, disconnect USB. Alright, you have just set up everything perfectly. Your quadcopter now is ready to fly. So give it a kiss, and now you can install the propellers, add the battery, and give it a test flight right away.